Hi everybody, welcome to Roger.
Come inside and have a look on the Transint project in the Mint Lab.
The Mint Lab has developed two prototypes, polymetallic nanocomplexes and aqueous core nanocapsules. We are also developing a method to assess mucodiffusion using fluorescence microscopy. Polymers and peptides are mixed in a solvent phase and precipitated by injection into an aqueous solution. The solvent phase is removed using a rotary evaporator. The suspension of nanocomplexes is finally centrifuged and freeze-dried to recover a final product that can be further characterized.
Aqueous core nanocapsules are prepared by a phase inversion temperature process. Oil, water, surfactant and salt undergo 3 temperature cycles. The evolution of the system can be followed by conductivity. After the last heating step, when the sample becomes transparent, the active ingredient is introduced right before a quench with an organic solvent. An interfacial polymerization is then triggered and lasts all night. Finally, the sample is transferred in water. A fluorescent dye can be loaded in the aqueous core nanocapsules for further characterization.
Lipid nanocapsule formulation is based on a phase inversion process. We work with 25, 50 and 100 nanometers LNC loaded with DIO, which is a lipophilic fluorescent dye. LNC have narrow distribution, a greater stability and a negative surface charge. In confocal laser scanning microscopy, the fluorescence recovery after photo-bleaching technique allows to monitor nanocarriers mobility by modeling the recovery kinetics in the bleach area. In FRAP experiments, a short height intensity light pulse bleaches the fluorescence signal from DIO-loaded LNC. Experiments were realized in water or in mucus. We obtain image sequence which show fluorescence recovery over time during FRAP experiments. The first step is to normalize the fluorescence recovery curves considering self-bleaching artifacts. Then, we use two complementary models to treat the data and estimate the diffusion coefficient. Collected images were analyzed using the Jensen model. It's a pixel-based statistical method that estimates the diffusion coefficient using intensity radial profiles at various times. More conventionally, data were also analyzed using the Bragas model that fit the average intensity in the bleach region with time.
All the data are then presented and discussed during a meeting with all the members of the Transint project in the lab.